Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiruddin Nombor matrik 09 DKM 22F1058. So today we will talk about area under the graph. So firstly, the introduction. Integration, also called antiderivative, is a mathematical technique used to find the area under a curve, which is significant application in fields such as science, engineering, and economics. Integration is the reverse process of differentiation. It is used to find function give it derivative. The basic idea of integration is finding the sum of infinitely small pieces of a function that resemble a curve and its area under it. Integration can be classified into two main types: definite integration and indefinite integration. Uh, the first question is by me. The question is, find the area bound by the following curve: y equals x square minus 4, y equals 0, x equals 4. So this is the graph. Uh, Finding the boundary y equals x square minus 4 and y equals 0 imply x square minus 4 equals 0. So x minus 2, x plus 2 equals 0, x equals negative 2, or x equals 2. From the graph, we see that x equals 2 is our boundary at A. The value x equals negative 2 is a solution to the equation above but is not bounding the area. Uh, Here why the graph is an important tool to help us determine correct result, so don't skip this step. The other boundary value is given by the equation of the vertical line x minus x equals 4. Boundary are a equals 2 and b equals 4. Set up the integral. This is the formula. A equals upper limit b below limit a f x dx equals the upper limit for the below limit 2 x square minus 4 dx. So for the solve is the upper bracket for the lower limit is 2 x square minus 4 dx equals 1 per 3 x cube minus 4x uh, upper limit 4 below limit 2 1 per x uh, multiply by 4 cube minus 4 multiply by 4 minus 1 per 3 multiply by 2 cube minus 4 multiply by 2. So the answer is 64 per 3 minus 16 minus 4 per 3 minus 8 equal 64 per 3 minus 60 minus 4 per 3 plus 8. The answer will be 56 per 3 minus 8, and the last answer is 32 per 3. The area bounded by the curve y equals x square minus 4, y equals 0, x equals 4 is equal to 32 per 3 square unit. That's all for me. I will pass to the next person. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anisah binti Azali. My metric number is F1063. My question is, find the area of the region enclosed by the following curves: x1 equals to y2 minus 2 and x2 equals to y. Since the first function is better defined as a function of y, we will calculate the integral with respect to y. This is the pictures we use. Y equals to x equals to y squared negative 2. In this case, the boundaries are determined by the points of intersection of both function. Remember that we want the y values since we will be integrating with respect to y. We need x1 equals to x2. So this implies that y squared minus 2 equals to y. But we want the equation is equals to 0, so we will put the equation into the calculator using the EQN mode. So we will move y to the left side. So we will get the equation is y squared minus y minus 2 equals to 0. So we put this equation to calculator. We will get the y negative 2 y plus 1. Y equals to 2 or y equals to negative 1. After that, we will continue the equation using a equals to integration symbol. Upper limit is 2 and lower limit is negative 1. Y minus in bracket y squared negative 2. We will multiply this negative symbol inside this equation y squared minus 2. So we will get 1 over 2. We'll integrate, and this is the integration after that. 1 over 2 y squared negative 1 over 3 y cubed plus 2y. This number we get from in upper limit and lower limit. After that, we will substitute the upper limit and lower limit into the equation. So we will get 1 over 2 multiply with 2 because the upper limit is 2, and then minus 1 low 1 over 3 multiply with 2 cube plus 2 multiply with 2, same as the lower limit. So we will just substitute the equation y to negative 1. So we will get 2 minus 8 over 3 plus 4 minus 1 over 2 plus 1 over 3 minus 2. So we get 6 minus 8 over 3 minus 1 over 3 plus 2 plus minus 1 over 2. So we get the last number will be 4, 4 1 over 2 or 9 over 2 square unit. So the area of the region enclosed by the curves x1 equals to y squared negative 2 and x2 equals to y is equal to 9 over 2 square unit. It's it from me. I will pass it to the next person. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arinah Najwa binti Muhammad Fadilah. My matrix number is 09DKM22F1080. I will be continuing with question number 3. The straight line with equation y equals to x plus 4 cuts the curve with equation y equals to negative x squared plus 2x plus 24 at the points A and B as shown in figure 3. A. Use algebra to find the coordinates of the point A and B. The finite region R is bounded by straight line and the curve and is shown shaded in figure 3. B. Use calculus to find the exact area of R. So, we have to find the coordinates of point A and B first for question A, and then we have to find the shaded area of R for question B. In order to find the coordinates of point A and B, we have to do simultaneous equation because we have two equation y equals to negative x squared plus 2x plus 24 and y equal to x plus 4. So when we do simultaneous equation for these two equation, it will become negative x squared plus 2x plus 24 equal to x plus 4. We move the x plus 4 to the left side and it will become x squared minus x minus 20 equal to 0. So next, put the equation into the calculator and you will get x equals to 5 and x equals to negative 4. So substitute the both values of x into the equation y equal to x plus 4. When x equals to 5, you will get y equals to 9. When x equals to negative 4, y equals to 0. So the coordinates for point A is -4, 0, and coordinates for point B is 5, 9. Now we'll be moving on to question B. For question B, you have to find the area for shaded region R. So in order for you to find the area for shaded region R, you will first have to find the area for the red shaded area, and then you will have to find the uh, area for blue shaded area, and then you have to subtract the product. So first, in order to find the shaded area for the blue, for the red one, it will be integral sign with the upper limit 5 and lower limit -4, negative x squared plus 2x plus 24 dx, minus with the area for blue shaded area, which is 1 over 2 times 9 times 9. And then you will have to integrate the equation for the uh, red shaded area. So it will be negative x cubed over 3 plus 2x squared over 2 plus 24x with the upper limit 5 and lower limit -4, minus with 82 over 2, 81 over 2. And then you will have to substitute the upper limit and lower limit into the x value. So it will be just as shown in the figure. And so you will get uh, 103 over 1 over 3 minus with negative 58 over 2 over 3 minus with 81 over 2, and you will get the area for shaded region R is 121 over 1 over 2 unit squared. That is all from me. Thank you.
In conclusion, integration is an important tool in calculus that has a wide range of application in many different fields, including engineering, physics, and economics. Thank you. That's all. Thank you.